Now children, you will see about the atomic orbitals and their shapes. So atomic orbitals, actually they are the three-dimensional region or the space in the nucleus in which the chance of finding of an electron is maximum. So see first the definition. So orbitals, they are also called as atomic orbitals. So orbitals or atomic orbitals are regions. They are the regions or spaces. They are the regions or spaces in atoms in which the chance of finding of an electron is maximum. So this is very important point. Chance of finding of electron is maximum. It means it is not going to provide you an absolute or accurate value. You know, you have seen about the quantum numbers, you have seen about the Schrodinger wave equation, and in Schrodinger wave equation also from quantum mechanical model, which is explained by Schrodinger wave equation. So gives what? Gives psi. You know this function, it is called as psi. Psi. This P is silent. It is psi. And it is what? It is nothing but it is called as wave function. It is called as wave function. And it has not, any physical significance, except it gives the amplitude of finding of an electron around the nucleus of an atom. So when we square psi, this gives the probability of finding electrons around the nucleus. This is very important part. Psi has not any significance. Significance lies in the psi square, and it is what? It is the probability of finding of electron around the nucleus of an atom. Like if you say there is the sun, so sun can have different dimensions. In the morning hours or in the evening, the intensity of sunlight is very low. If you want to dry our clothes, we cannot dry. Our clothes take much more time to dry in the morning hours or in evening hours. What does it mean? That the intensity of the light is much less. But what happens in the daytime? In the noontime, what happens? The intensity or the strength of the sunlight is very high, or is it at its peak? Maximum value is there. So this is there. The intensity is the probability, and as a result, the close die. So just I am comparing here to explain you so that you can understand easily. So children, you have seen that psi square is equal to probability of finding an electron around the nucleus of an atom. Nucleus of an atom. Now you have previous knowledge. In quantum numbers we have seen that orbitals are of name 4 types. Means they are significant and all the explanations are done by these only, and they are S, P, D and F. We always use small letters to represent. We do not write capital letters. It is symbolic. It is fixed. It has been given a certain definite norms by the OPEC committee or by the entire world. So S, P, D and F. Now children, coming to the how we determine the shape determination. How we determine the shape of an orbital. Actually children, there are different mathematical quantities, mathematical operators. You all must know it. Like see, this is theta, then we have this phi. So they are the called as angle variables. They are called as angle variables. You know, theta and phi, they are angle variables. So there is the relation with the angles. Their angle variable is there, and so we have this. Similarly, children, we have the radius. We have distance. They are the length variables. They are the length variables, and they enables us. They enables us to know about the shape of an orbital. That what is the shape of an orbital, and the shape of an orbital is determined by drawing or representing the finding or probability of electrons. So we draw certain graph to find out the shape of an orbital. Now see how. Now children, you have seen that the variables, distance variable and angle variable. So see how we draw. So you know, there is the 1s orbital, there is the 2s orbital. So there is the 1s and 2s. They are based on the energy level representation. You have seen in the quantum number. So here I am drawing for the S orbital. So for the S orbital, there is the representation like this. There is the representation like this. On one axis we have the radius. As I have said, this is what? This is the distance variable, and here we have the psi. This is the psi. On this axis there is the psi, that is the amplitude. This axis there is the r. But you know what happens? Psi has not any physical significance. So what we have to do? We have to draw for the psi square. And here for this distance r can be in basically it is in nanometer, it is in nanometer. So exactly when we square, so what will happen? We'll have exactly location. Here it is slightly just touching the axis edge, but on squaring this, it runs just attached. It runs just attached to the axis, on this axis as well as this axis. How? By squaring the value of psi. So, on this basis, the S orbitals have this type of representation. S orbitals have this type of representation. And here there is the central portion. And what it is? visible that in the s orbital, this is the central portion, and the central portion has the nucleus, and this nucleus, the probability of finding of electron is maximum because electrons are negatively charged, nucleus is positively charged. So as we go away from the nucleus, the electron density decreases. As we go away, slowly and slowly, there is a progressive decrease. There is a progressive decrease. This uniform distribution of the electron density indicates that there is a progressive decrease in the density. But density never becomes zero. The probability of finding of electron is always there. So this is the, just like it is spherical. It is spherical ball, and electron density is maximum in centers. It is maximum in centers. Electron density is maximum in centers, and it decreases but never becomes equal to zero. Never it becomes equal to zero. Just like a soccer or just like a football. There is always a possibility of finding of the electron density. And so this is about the S orbital. Now coming to 2s. Now coming to 2s representation. So in 2s, it is same. Here there is slightly more attachment. Just this is the representation. Just it differs from the 1s. It is more in density. But what about this? On the squaring of the value. So initially it is like this. It is coming here, and here as it is 0, you may say here 0. At certain point the value becomes almost 0. 0 does not mean 0. The chance of finding of electron is very, very less or scarce. Now at this point it becomes less, but then there is the increase in the value. The value then increases to certain limit, then it becomes here, and then it runs parallel. It runs parallel to the axis. Again see, on squaring the size, we have the size square. So on the ends, the probability becomes almost 0. Again it increases, and the line runs parallel to the axis. So this is the graphical representation. Now the pictorial representation, or how we represent the picture. How we represent the picture. So in the picture, again there is the center of the nucleus. The center of nucleus. Here there is the electron density. Electron density is there, as it was there. But now the electron density, it is never coming to the value, but here it becomes 0. But now around this there is an area. There is an area in which the chance of finding of electrons, is 0. This is the representation of 2D. And this place where there is no electron density, it is called as node. So node has no electron density. So similarly, we can draw for the p orbitals, draw for the d orbitals, draw for the f orbital. So this is about the 1s and 2s. Coming to p, it is also there. P orbitals, again, p orbitals, they are double set. They have the 3 axes. And we draw like this. Like this be x, this be y, and this be j. Px, py, and pj. So this is about this.